In this video, we're going to discuss a couple of basic rational functions and how to graph transformations of them. So when we talk about a rational function, we're talking about a function that looks like this. Rational has the word ratio in it, and a ratio can be written as a fraction. So it's going to look like a fraction, but specifically the numerator and denominator are going to be polynomials. So we're not going to see any square roots or anything like that. It's just going to be a polynomial in the numerator and a polynomial in the denominator. And these functions commonly have what we call asymptotes. And there are different types of asymptotes. So one type that we're going to look at is a vertical asymptote. And a vertical asymptote is just a vertical line that the graph approaches but does not touch or cross. A vertical asymptote comes from a value of x where the function is undefined. And so since we can't have a point at an x value that we can't substitute in, there's a couple different things that can happen, but one possibility is a vertical asymptote. And then we can also have a horizontal asymptote. Which is a horizontal line that the graph approaches. I've given a slightly different definition here because for some functions it is possible for the graph to touch or cross the horizontal asymptote. That's not the case for vertical asymptote because it's an x value that's not allowed, but for a horizontal asymptote it is possible that somewhere in the middle of the graph it touches or crosses the line. But the point is, as we head toward the left or the right end of the graph, or maybe both ends of the graph is going to approach the line without touching it at that point. So like I said, we're going to look at two basic rational functions here. Let me give us a couple set of axes to draw on. These functions that we're going to discuss here are commonly used. If you go on and take a calculus course or something, it's going to be very helpful to be able to recognize what the shape of these graphs are and how to recognize when you're dealing with a transformation of one of these graphs. So maybe it's basically this graph but it's been shifted or something like that. So it's helpful to know how to do a quick sketch of what that looks like. So one of the basic functions that we deal with a lot is y equals 1 over x. You can see here that the denominator is x, so we would not be able to substitute 0 for x here because we would have a denominator of 0. And because of that, this function has a vertical asymptote. The line x equals 0 is the vertical asymptote for this function. So the y-axis is a line that the graph's going to approach without touching. This graph also has a vertical asymptote. If you imagine taking larger and larger x values and plugging them in here, like say you plug in 10, then you have 1/10. Say you plug in 1,000, then you have 1 over 1,000. Say you plug in 1,000,000, then you have 1 over 1,000,000. The value of the fraction is going to be getting really, really small. But it's not going to go negative, and it's not going to ever become 0 because we can only get 0 by doing 0 divided by something. And so what happens is as the graph, as the x values get really big, as we head toward the right end of the graph's going to approach a y value of 0 without ever getting there. And the same is true as we head toward the left end of the graph and we take more and more negative x values, -10, -1,000, -1,000,000. It's still going to get closer to 0. So we have these two branches of this graph that approach the axes without touching, because remember we had a vertical asymptote x equals 0 and we have a horizontal asymptote of y equals 0. And if you substitute a positive value for x, you get a positive y value for this function. So we have this branch in quadrant 1. And then if you substitute a negative x value here, you're going to get a negative y value because you're going to do 1 divided by that x value. So if x is negative, y is negative. So the other branch is in quadrant 3, and it also approaches both of the asymptotes without touching them. The other basic rational function that we see a lot is 1 over x squared. Similarly, for this function, the only value you have to exclude from the domain is 0. You can't plug in 0 for x, but you can plug in any other number you like. And so this function also has a vertical asymptote of x equals 0. And similarly to the first one, if you take larger and larger values of x, your y value is going to get closer to 0. And if you take infinitely negative values of x, it's going to approach 0 as well. The difference here is if you plug in a positive value for x, you get a positive y value. That's actually the same. But the difference is if you substitute a negative x value here, you're going to square it, which means you're going to multiply it by itself. You're going to need a positive result. And then you're going to do 1 divided by that positive number. So if x is negative, y is still positive for this graph. So we still have 2 branches that approach the asymptotes. One of them is still in quadrant 1, but the other one is going to be in quadrant 2 because a negative x is still going to give us a positive y value. Now, like I said, if you go on to a calculus course, for example, you might see functions that look like similar to these, but they've been altered a little bit. And we can think of those as transformations of these 2 basic functions, just like we did transformations of other basic functions like y equals x squared, y equals square root of x, those kind of functions. And then we shifted them, we stretched them, we reflected them over an axis. We can do that with these functions as well. So let's look at an example here. So here we have 1 over x minus 1 minus 2. Okay, the first thing we have to do is decide which of these 2 functions is this a transformation of, right? And so to tell the difference, you're just going to look for, is there that exponent of 2 or is there not an exponent of 2? And so that will tell you then which of these originals we're starting with. So since we don't have an exponent here of 2, this is a transformation of the first basic function we graphed there, y equals 1 over x, which looks something like this. It has these asymptotes. And so now we're going to graph this transformation. And we've discussed before that anything happening inside the original function with x causes a change in the x direction, the horizontal direction. So we've gone inside the denominator of this original function and we've replaced x with x minus 1. So that's going to cause a horizontal change. And since it's subtraction, it's going to be a shift. So this is going to cause the graph to shift 1 unit to the right. And so what happens when we shift these functions is the asymptotes move. So we were approaching the y-axis here. Now that we're shifting this entire graph to the right, this vertical asymptote is going to move 1 unit to the right as well. And it's going to be now the line x equals 1. And we can see from the equation, right, if we substitute 1 in for x, we would get a denominator of 0. So we cannot have a point on the graph of this function that has an x value of 1, which is why the graph is not going to touch or cross that vertical line. We usually draw asymptotes with dashed lines. I don't tend to draw them on the axes because it's just kind of hard to see if you're drawing a dashed line on top of the axes. I usually just make a note of what the equation of the asymptotes are like that. But anytime they're not on the axes, we do want to draw in that dashed line so we can see where the asymptote is. All right, now we have this minus 2 on the outside of the fraction, so outside the original function. That means it's a vertical change. And it's subtraction, subtracting 2, so this is going to shift down 2 units. And so the horizontal asymptote on the original was y equals 0. That horizontal line is going to move down 2 units as well. And so this is going to be our horizontal asymptote. And the branches of the graph shift as well. So all of the points that were on the graph shift right and down as well. So this branch is going to be up here approaching both asymptotes. And the branch that was in quadrant 3 also comes right and down, and it's still approaching both asymptotes. We don't typically need to plot specific points on these. You can just plug in some x values and get some points if you need to. Most of the time we're dealing with these functions, we just kind of need to know what are the asymptotes and what does the rough sketch of those two branches look like. All right, here's another example. This time we see an exponent of 2. So that tells us that this is a transformation of y equals x squared because we have that exponent of 2. This is our original function. So this is the one that has branches in quadrants 1 and 2. Let me just do a quick sketch of that here for us to have as a visual reference. And then let's look at this new function. So if we go inside where x is, we're still seeing just x squared. That did not change. So since the denominator is still x squared, we have no horizontal change here. But we do see a couple of things happening outside of the function. So we have a couple of things happening in the y direction. First we have this negative sign here. What does that mean? Well, it's basically negative 1 times the fraction. Right? So we've taken our original function and we're multiplying it by negative 1. So that is going to be a vertical reflection. So what happens just from that is the two branches of the graph reflect down over the x-axis, and they're going to be in quadrants 3 and 4 now. Remember, reflections always happen before shifting because order of operations tells us we multiply, then we add or subtract. So that reflection is going to happen first. Asymptotes haven't changed. And then after the reflection, we are adding 3 outside the function, so we're going to shift up 3 units. And so when we do that, nothing happens with the vertical asymptote, but the horizontal asymptote is going to move up 3. This horizontal line is going to come up 3 units, and it's going to be here, so it's going to be the line y equals 3 now. And the branches that got reflected down are now going to shift up along with it, and so it's going to look something like this. Again, the branches are approaching both asymptotes without touching or crossing them.